Hello Kannada channel. This is Suhas, your chemistry master teacher. Students, how are you all? I hope everybody is safe and doing extremely great, students. Students, you know, right? Finally, class 10th exams are over and now it's time to foundation class. Today, we are going to discuss entire metals and non-metals unit with foundation courses. Okay na? Artha aita? We discuss entire metals and non-metals unit with foundation courses. You know, right, students? For our Vedantu, we completed totally 10 years. Our Vedantu completed 10 years anniversary. Today is Vedantu's 10 years anniversary. Okay, students, finally, the milestone is completed. Students, before starting the class, please let me know in chat section. The PPT is clearly visible and your Suhas sir is visible and the voice is clearly audible. Very important. Students, let me know. The voice is clearly audible and the PPT is clearly visible. If it's visible and audible, then let us know, my dear students, in chat section. Yes. Anything special is there today? Yes, sir. 10-year anniversary special. I give one gift here, students. We announce an new big reveal in Monday. Okay, stay with us. Stay with us and join Monday session and share the channel for your friends. Monday, you guys have a big announcement. Okay, come on, let's discuss entire metals and non-metals units. This video, specially delicate or dedicated to JEE students, Olympiad students, IIT students, and NEET and Foundation and NTSC students. Students, in end of the session, we discuss the previous PYQ questions of entire NEET syllabus, entire Olympiad, entire JEE questions, everything we discuss, students. Okay, my dear students, come on, let's start with first learning outcome. The first and important learning outcome, physical and chemical property and octet rule and ionic bonding. We familiar with this, right, my dear students? Let's start with physical property. In Stone Age, it's nothing but before BC, before Christ, what happened in starting days? We know our evolution. Monkey to what? Monkey to, come on, let us know. Monkey to human, right, students? Manganinda Manava, we already know. In Stone Age, what happened? The people are there, what they use it for tools? They use it stone. They make tools as a stone and kill the animals and eat that animals. Okay, my dear students, but what happened after some time? They only discover something. What they discover? They discover copper metal. They mix copper metal with stone and using instead of stone, they uses copper metal as a tools, my dear student, and iron is coming and other thing is happening. Kingdom, we already know. These are the few example for metals or tools, metals tools, copper metal tools, iron metals tools, everything is there, my dear students. Here we have few example, common metals and non-metals example is there. We use iron. Yes, sir. We always use iron. Where we use to build any building. To build any building, we need iron is very important. Nowadays, steel is coming. Nowadays, we use steel pipes and other things. We use steel. And in before age, nowadays also, in some cases or in some places, iron is very important. Right, my dear students? Copper. Whenever we saw in outside what happened, some lines are going, right, my dear students? Electrical wires. The entire electrical wires are made up of copper metal. Right, gold, oh my god, ornaments, right, my dear students? Whenever the function is happen, you and your family, entire family wear some necklace, some saras and other things, right, my dear students? Some necklace, some bangles, everything made up of gold. It's look like a wow. Just look like a wow. Aluminium, sodium, these are few common metals we use it in everyday life. These are the metals we use it in everyday life. And also non-metal, oxygen. How can we live, students? How can we live without oxygen? Oxygen like study for entire students. Oxygen like study for students, right, my dear students? We need study, right? Without study, we cannot live in the life. We in this society. If you are really educated, then society gives some respect for you guys. That's why education is important. For example, you give some respect for me, right? Why you give respect for me? Because I am teaching here. Before teaching, I am also student like you. In before 1 year only, not before a year, before 6 months, I am also students like you. But I don't have any respect on that time. But after the studies, I come to one position. Now you guys give some respect for me, right, my dear students? That's why study is very important. Don't distract anywhere, especially in this time. For especially the middle class people, I am also middle class students, only students. I am also middle class. I am also one middle class. But what now? Don't distract anywhere. Just focus on the study. Definitely one day you will success. Okay. Then coal, sulfur, these are the few common non-metals what we use in everyday life. Then after that, here one important example for metals and non-metals is there. Mercury is a metal which is liquid at room temperature. Which metal is liquid at room temperature? Important for your foundation and also competitive work. And bromine, which is a non-metal. This bromine is a non-metal which is liquid at room temperature. Non-metal. Which non-metal liquid at room temperature? Bromine. And mercury is a metal which is liquid at room temperature. Metal is liquid at room temperature. Next, more the physical properties. Students, we know, right? We classify metal. This molecule or this atom, this element as a metal, this element as a non-metal. How we classify? How we classify? The scientists, how they classify? Depends upon their physical property. What they shows physically, what they show some property, what they shows chemical properties. Depends upon this, they classify it. Very simple. Let's start with, we have mainly 7 physical properties. First one, hardness. What is the meaning of hardness? For example, take one iron nail. Iron nail, and apply some force and try to break that one. It's not happened, right? Why? Because metal. Iron is a metal. Iron nail is made up of iron metal. That's why metals are generally hard. But here some exception is there. Exception, except. What is there? Some exception is there. What is the exception? Sodium, lithium, and other one potassium. These are alkali metals. These are soft in nature. We can easily cut these metals by knife. Here some exception is there. Okay, it's done. Then non-metals. These are soft in nature. Appearance, lusters. What is the meaning of appearance? How it look? Whenever we saw that one, they have lusters. It's nothing but they have shiny surface. The pure metal, it has in shiny surface. Or it show a shiny surface area. Very simple. Okay, my dear students. Similarly, non-metals are non-luster. Here also some exception is there. The expect. Which one? Iodine. Iodine is also non-metal. Adhan bittu in miktavella enagirutte lusters agirutte. Similarly, sonority. Sonority is nothing but the ability to produce sound. Metals or sonorous is nothing but metals can easily produce sound. In the case of non-metals, non-sonorous, here there is no exception is there. And here thermal conductivity. In this case, metals are good conductor of heat, my dear students. Non-metals, poor conductor of heat. We cannot. It's nothing but we cannot eat the non-metal. If you eat the non-metal, it easily converted into other state. It's nothing but, for example, any non-metal you can take. Okay, students, and after that, electrical conductivity, we know metals always good conductor of electricity. Example, copper metal, and other some examples also there. And also electrical conductivity, it is also poor conductor of electricity. Expect diamond. Not a diamond, sir. Graphite. Why, Suha, sir? You are confusing. I am not confusing, students. I am checking your IQ. That's all. Poor conductor of electricity. And graphite. Graphite is a non-metal which is what? Which is, yes, it's a non-metal which is poor conductor, not a poor conductor, good conductor of electricity. What is the meaning of ductility, students? Ductility is nothing but very simple. This is a property, this is an ability, or this is an ability to drawn into wire. It's nothing but metals we can easily drawn. We can easily drawn metal to a wire-like particle. And also non-metals are non-ductile in nature. Malleability. Metals are malleable in nature. Non-metals are non-malleable. Malleability is nothing but it is drawn into paper-like structure. It is drawn into, if we beat, take any example, heat the metal, then beat by using an hammer, then we can easily make them into sheet, thin sheet. This is called malleability. Students, here I give one homework question. What is that homework question? Here, let us know, let me know, or let us know in comment section or chat section. The students, those who watch the video after the live, let me know in comment section. Okay, very simple. Which metal is a most malleable and most ductile metal? Comment it on comment section, either in chat section. Okay, my dear students, this is about physical property, and we have some exception is there now. Exception, no sir, exception. Yes, exception is there now. This one, these are we already know. Then these are we know. Next, more of the chemical properties, students. Very simple. Whenever we heat the metal in the presence of oxygen, we are already familiar in NCERT. Yes sir, magnesium ribbon. Then it is heated. What happened? White dazzling flame is give white color ash. It is nothing but magnesium oxide. It gives magnesium oxide. And here also we have one important note is this. Students, the reaction of metals like sodium and potassium, air is so vigorous, then they catch fire is kept it open. What happened? If you put sodium or potassium in open surface, what happened? It catches fire. It catches fire. It catches fire and it blasts. That's why we always, to protect them and prevent accidental fires, they are kept immersed in kerosene oil. What we do? They are kept immersed in kerosene oil. ಏನು ಮಾಡ್ತೀವಿ ಅದನ್ನ ನಾವು ಯಾವಾಗೂ kerosene oil ಇಡ್ತೀವಿ. Very simple, my dear students. Next one, reaction of metals with water. What happened? Whenever we react or whenever we heat the water or whenever we dissolve the metal with water, what happened? They form metal hydroxide. For example, magnesium. First, magnesium reaction with water. First, it converted into magnesium oxide, sir. Why? Because in water also oxygen is there. First, it's converted to magnesium oxide, and after it react with further molecule of water and form magnesium hydroxide, MgOH2 plus hydrogen gas. How we can confirm this hydrogen gas? The evolution of hydrogen gas. How we confirm, students? By using pop-up sound. When you take burning stick near to the hydrogen gas, where the gas is releases, when you take the burning stick near to that gas, what happened? It forms pop-up sound. We right, students? We are already familiar with that one. Yes, my dear students. Anything is else? Any doubt is there? Still any doubts? I hope nothing doubt is there. Then come on, let's move for the types of metal oxides. Students, metal oxides always behaves as two forms. It is always behaves as basic forms. We already know in acid, base and salts, acids are the solution or the what, whenever the non-metal oxide. Acids is nothing but the solution form of non-metal oxides. We are already familiar with them, right, students? Non-metal oxides, right? Then bases are nothing but metal oxide solution. For example, let's take example of NaOH. In NaOH, sodium hydroxide, alkali. In sodium is there. Sodium is nothing but metal, right, my dear students? Yes, sir, it's metal. Yes, students, what happened? Whenever the metal is reacted with oxygen, they forms metal oxides only. These metal oxides, they shows basic nature. Basic nature is nothing but whenever it react with acid, metal oxides react with acid, which yield metal salt. And also we have two metal oxides. They behave as amphoteric. It is also called amphoteric metal oxides or amphoteric in nature. It's nothing but they shows both acidic and as well as basic nature. It's nothing but this Al2O3, aluminum oxide and zinc oxide is there, my dear students. These both are react with, they are react with both acid and base. They react with both acid and base. I hope it's clear, my dear students. Then move on to the third chemical property, reaction of metals with acids. What happened? Same, sir. Hydrogen gas releases, salt is forming because metal acts as a base. Metal is a basic in nature. That's why very simple. Then after that, by depends upon rate of formation of hydrogen bubbles. How we know? Whenever the magnesium metal is inserted, the hydrogen is releases in the form of bubble. This is one series here, one series is there. This series it's called as a reactivity series. And next one, reaction of metals with solution of other metal salts. Very simple, displacement reaction is happened, students. What happened? We know, right, students? Whenever the metal is highly reactive than other metal, it can easily replace that. For example, we have two students. One student named Suhas and another one any people. Okay, another one Krishu. He is my favorite student, right, students? What happened? If Krishu is stronger than me, Krishu can easily push those from a ring or from a WWE anything. He definitely, yes sir, he definitely pushed out you. Right, my dear students, what happened? Depends. Most reactive metal can displace with this one. This reaction is also called as displacement reaction. By using this displacement, we arrange metals in the decreasing order of their reactivity. This series is called as reactivity series. Here, up to aluminium, we call these 5 metals as a highly reactive metals. In the metallurgy process, in the metallurgy or in the extraction process, this is very important. Extraction of metals is completely depending upon their reactivity. And this zinc, iron and lead, these 3 acts as an moderately reactive metals, and hydrogen is never be considered as a metal and as well as non-metals also. Then after this, copper, mercury and Ag means silver. These are called least reactive metals, and also Aluminium, sorry, AU is not aluminium, my dear students. Gold and platinum, these two called as noble metals. What is noble metals? Few metals like silver, aluminium, sorry, aluminium, always aluminium is coming. Gold, platinum do not react with air even at higher temperature. What happened? Even at higher temperature, it never react with air. Therefore, these metals are called as an noble metal. These metals are called as a noble metals. For example, these are noble metals. Students, you know one thing. These noble metals also we can easily dissolve in one solution. This solution is called aqua regia. It is a highly corrosive and fuming liquid which is used to dissolve inert metal. What is aqua regia or royal water? It is a freshly prepared mixture of concentrated HCl and concentrated HNO3 in the ratio of 3:1. Whenever we dissolve or whenever we dissolve this, like we dissolve these metals, either this metal is dissolved in either HCl or HNO3, anyone it is dissolved. We can easily differentiate, or we can easily divide these two, or we can easily differentiate concentrated HCl and concentrated HNO3 by using some separated techniques. And after that, in concentrated HCl, gold is there or any inert metals, we can easily separate it, those gold. Okay, very important. Here one important question is there, interactivity part. What is interactivity part, sir? Activity is there na students. It is also, this question is completely related to that activity, NCERT activity. Okay, the question is very simple. Aqua regia is used to dissolve reactive metals or noble metals. Yes sir, the answer is noble metals. Come on, let's solve here. Few questions is there. These are the PYQs of JEE, NEET and other questions. The question is, property of metals to make sound upon hitting is called sonority. Yes sir. Ductility is nothing but wire. Malleability is nothing but sheet like structure. In class 9th we already discussed this thing, right students? In whenever you enter class 11th, on that case, on that unit, chapter 11, in chapter 11, no, not in chapter 2 we have that one. Okay, it is very important. Okay my dear students, I hope it's clear. Then come on, now it's a quiz time. First question, metal reacts with solution of other metal salts by which reaction? Let us know in chat session, students, the answer. Let us know in chat session. What is the meaning of combination? Combine. No sir, here combination is not, decomposition is not also. Either this. The answer is option D. Next one, ZNO is a amphoteric. It shows both acidic and both basic character. Which one is kept in message? Sodium, because it is highly reactive. Machine achieved. Oh yes my dear students. Anything else? Any doubt is there, students? Let us know. If you have any doubt, let us know, my dear students. My dear army, let us know. Now let's move for the next question. What happens when you take an electron from an atom? What happened? It forms positive ion or negative. Whenever you take that thing, it forms positive cation. Next, move on to the octet rule and ionic bond. Students, I back within 5 minutes. Please stay with me. Please stay with the live. I am back. Let's take some break here. S, my dears. 1 second. Everybody. Yes. Super. Come on, let's move with octet. We know, right, students? Elements have the tendency to attain a completely filled valential configuration. Depends upon this inert gas. Similarly like this one. Stability. We already know. In class 9, you already discussed these things. Stability of atom is completely depend upon two important configuration. First one is duplet configuration only for K shell. We already know we have shells K, L, M, N. For K shell, it's an first shell. L shell, 2, third, 4. We already know Borburello, the electronic distribution or the not an electronic configuration, is electronic configuration, electron distribution for every atom, everything we already know. This is also octet configuration. After K shell, all other L shell and second subshell and other things, what happen? They fill it totally 8 electron. If it have 8 electron in its valence shell is nothing but outermost shell. Then these type of compounds are called as a stable compound. For that metal, what happens? Metal have 1, 2, 3. It is a maximum valence electron. They are present in metals. What happens? That's why metal always form positive cations. What happens, students? It's always form positive ions. It's nothing but they lose its valence electrons. They always lose. Instead of gaining 5 to 6 electrons, they can easily lose their electron. Right, my dear students? That's why metals are called as an electropositive element. For example, sodium. What happens? Sodium, they lose its 1 electron, then it forms sodium ion, Na plus ion, cation. Students, whenever in this case, cation is nothing but positive ion in ion dissociation form. Whenever you enter to extraction path in the electrolytic solution or in the electrolytic reduction or in electrochemistry, anion is nothing but positive cathode, anode is nothing but positive electrode, cathode is nothing but negative electrode. In that, it happened in reverse. It is reverse form. Very simple. Then also non-metals. What is non-metal? Is called electronegative elements. Why? They have 5, 6, 7 valence electron and then they readily to take electron or gain electron. They are always ready. Whenever any other metals give the electron, they already wait, who give, oh, give, okay, give for me, I need that one. They told like this, students. Okay, students, that's why they are always electronegative elements. Electronegative elements ಆಗಿರುತ್ತೆ. For example, take an example of chlorine. What is the number of protons are present in chlorine? 17, sir. What about chloride ion? Chloride ion 18 electron is present. What happened? It accept or it gain 1 electron and it becomes electronegative compound. This about this one. And this take and give manner, these two elements forms on bond. This bond is called ionic bond. These compounds are called electrocovalent or electrocovalent compounds. The cation and anion being oppositely charged attract each other by electrostatic force of attraction, Coulomb force. They are always attracting. Positive charge always attract towards negative end. Negative end is always attract towards positive, negative. Right, my dear students? Then it forms sodium chloride molecule. This bond, what is ionic bond? This is a chemical bond which is formed by give and take manner, or one electron give the electron and one element give the electron and another one accept the electron. This is a criteria behind entire electrocovalent or ionic bond. Here, students, we have one question here. Ionic compounds are also called which compound? Covalent or? No, sir. Carbon. Whenever carbon is present in molecule, then this carbon form covalent compound. Similarly, ionic compounds always form electrocovalent compound. Ionic compound ಏನು ಮಾಡುತ್ತೆ? They forms electrocovalent. Yes, my dear students, it is also called as an electrocovalent. Here, one question is there. What is that question? Suha sir? Which of the following attains a duplet configuration? What is the meaning of duplet? Duplet is nothing but it has 2 electron in its valence shell. Obviously, what is the electronic number or the atomic number of lithium? 3. Sodium, it has more than 11. That's why it's not a correct answer. Duplet is nothing but it must and should be consist only 1 electronic shell, only 1 K shell. Magnesium is also not there. Instead of Li, if Li plus is there, then it is what? It is have duplet configuration, but the correct answer is helium. Next, move on to the quiz time, my dear students. Here, identify the ionic compound. Oh my god, very simple, students. Here, I give simple trick. Ionic compound is nothing but it is formed between, most of the time it is formed between metals and non-metals. Come on, let us know in chat section. Everybody, let us know. Let us know, students, fast. Yes. What is the answer? The answer is option A. Is an ionic compound. Second question, my dear students, which of the following forms an anion? Anion is nothing but it must and should be non-metal. Metals always form cation, right? That's for magnesium is metal, sodium is also metal, iron is also metal. That's why the answer is bromium. Ionic bond involves the transfer of electrons. Yes. Come on, let's move for the second session. Second session is nothing but second part of the class. Next learning outcome is covalent and coordinate bonding and metallic and hydrogen bonding. If we done this, then we move on to the extraction part. Okay, students? Come, let's do it covalent and covalent. We already know covalent is nothing but it is formed. It is also chemical bond formed by mutual sharing of electron. We already discussed in N-type this related covalent concept in where? Carbon and its compounds, right, students? These are the single bond. We have three types in covalent bonds: single bond, double bond, triple bond. These are the example. Everything we already know. It is classified into single bond, double bond, triple bond, and polar and non-polar. Okay, we already know single bond is nothing but mutual sharing. Only one electron is shared. Here 2, here 3. Example: N2 molecule, CO2 molecule, HCl molecule. It has a most stable, less stable, least stable. Okay. Then polar covalent formed due to unequal sharing is nothing but whenever hydrogen is there, it is forms a polar bond. Whenever the same molecule is forming, then it's not called as a non-polar. It's nothing but here formed due to unequal sharing. For example, here hydrogen give 1, but fluorine also accept 1 only. But what happened? Electronegativity of combining atom is different. Hydrogen is low compared to this one is high. That's why. Okay, my dear students, I hope it's clear. Coordinate bond, we already know. One bond give the electron, one acts as an acceptor. They are cation. It's nothing but their form. It is also called dative bond. Donor acceptor bond is there. It is called dative bond. Okay. Then it's clear. Here one question. Okay, just leave this one. First question. What is the question? Which of the following molecule does not have coordinate bond? Does not have. The answer is option C. CO3 minus. Contains only covalent bonds. A coordinate bond is present in carbonate ion. Here, this only have covalent bond. Okay. Then after this, the compound having covalent bond is which one? The answer is option C. CO2 it have covalent compound or covalent bond. Next, move on to the metallic and hydrogen bonding. Very important concepts, my dear students. What is the meaning of metallic? Metallic nature. Whenever the metals, we already know metal acts as a what? It acts as a electropositive in nature. Metals always electropositive in nature. ಏನಾಗುತ್ತೆ ಮೆಟಲ್ ಯಾವಾಗೂ ಅದು electropositive ಆಗಿರುತ್ತೆ. What happened in this case? Metallic bonding is a type of chemical bonding that arises from the electrostatic attractive force between conductive electron or conduction electrons. 1 second, students. Sorry for the students. Yes. Then this thing is happen. What happens to us? Here very simple. What is that one? As pen. This thing. Hydrogen bonding is nothing but formation of hydrogen with other metals or non-metals. Very simple. Here one question is there metallic bond arise due to repulsive force? No, it is false. It is due to attractive force. Let's solve. Metal lose electrons to become positive ion. Which time? Which of the following can form hydrogen bond with hydrogen? Which one? They can form oxygen. They can form with hydrogen. Here, hydrogen. Everything is done. Free electron. Next mode of session 3. Here we are coming to main part of your class 10th exam. Minerals and ores and extraction of highly reactive metal. After this, moderately reactive metals. After that, less reactive. And last step, electro-refining method. Electro-refining. And after that, alloys. If you done these 7 totally. Sorry. In another learning outcomes we visit that. Which one? Corrosion topic. Corrosion also there here. Okay. I hope it's clear. Yes, students. Minerals and ore. What is the difference between minerals? We already know. This is our earth. This first layer is an earth crust. The elements, something is obtained in earth crust, right? The elements or compound occur naturally in earth crust. These are called minerals. What are minerals? The elements or compound which occur naturally in the earth crust. These are called minerals. Very important, my dear students. 2 marks. One question is definitely they ask. What are minerals? Example. We have so many example. Rock, gems, clay, bauxite. But ore is different. Students, we know clay and bauxite both are mineral, but both contains aluminium only. But in bauxite only we can easily extract the ore by using some probable method or profitable method or profitably convenient method or some relevant method. These are called ore. Ore is nothing but it is also a mineral. The mineral from which metal can be extracted. It is called ore. This process is called metallurgy. The process of extracting metal from their respective ore in a profitable and convenient manner. This is called metallurgy. Okay, my dear students. In basic step, these are the 3 basic steps of metallurgy. In first step, we do concentration or enrichment of ore. What happens to this? Whenever you look in our childhood, what happened? The entire building is built by using soil. What happened in before using that soil? The workers, what they do? They simply filter that soil, because in which soil we can see some sticks and other things. That's why they do some filtration. That's why here also, whenever we extract the ores, what happened with ore, the respective ore, what happened? Some salt is there, some rock salt is there, some rocks are there, and soil like material is there. That's why we need to remove this. If we not remove this, we cannot get we cannot get that metal. We cannot get that. What we target metal is there, we cannot easily get it. That's why what we do, we simply filtrate that and we remove those particles in the enrichment process and extraction of metal. Students, extraction of metal is completely depending upon their reactivity. We have different steps. We have different manner for highly reactive metals. We have a different approaches there for least reactive metals and also moderately reactive metals. Almost these two are same, students. Moderately reactive metals, least reactive metals, almost same. And after that, refining. Why refining is important? Because whenever you guys buy some fruits from outside, what happened? Your mother or your father told, your brother told, hey, before eating, wash that fruit. Why? Because it has some bacteria. Similarly, whenever we extract the metal from their enriched ore, we have some other metals. Because few metals can easily form a bond. For example, they are like brother and sister or brother and brother. That's why we need to remove that impurity metal or impure metal. We want only pure metal. That's why refining is very important. Electrolytic refining method. This thing is happened. This is an first step, concentration. We already told. Ores that mined from earth are usually contaminated with a large amount of impurities like soil, sand, mica, rocky materials, limestone. These are the examples. Then these impurities which are present in the ores are called gangue. The gangue is nothing but the impurities present in the ore. When in the enrichment process we remove this gangue, then we get concentrated ore. Here we have few example for ore, students. Name of the ore, rock salt. It is correspond to the What is present in rock salt? NaCl, sodium chloride. Which metal is extracted by rock salt? Sodium metal. Aluminium by bauxite ore. Zinc by zinc plant. Zinc by calamine. Manganese by pyrolusite. Right? Pyrolusite. Right, my dear students? Here one simple question is there. Aluminium aluminium is the ore of bauxite. True or false? Let us know. Let us know, everybody. Let us know in chat section, everybody. What is the answer? Is done right? Yes, it's false. Come on, let's discuss here. Identify the mineral aluminium, chlorine, clay. The mineral is clay, right? Which time during concentration gang gives removed, then something is happening. Next, move on to the extraction of highly reactive metals. Students, highly reactive metals, they have high affinity towards their allied forms and their oxide forms. That's why these are highly reactive metals. Okay, these are obtained in the form of an rock salt, bauxite. These are example. By using reducing agent, we can't extract. By using, we have a special technique. It is called as an electrolytic reduction. Very simple, students. What happened in this process? During electrolytic reduction of NaCl, two inert electrodes are submerged in molten NaCl. We take two electrodes. Basically or commonly, these electrodes consist graphite only. These are graphite electrode only. Students, positive side of electrodes are called anode, negative electrode are called cathode. What happened in molten state, molten NaCl state, sodium chloride is there na, it dissociated, Na plus is formed and Cl minus is formed. This chlorine is there na, it is always attract towards anode. Why, sir? Because negative, it have negative charge, that's why it move towards anode electrode, and sodium has positive charge, it move towards cathode electrode. And here what happened in cathode, Na plus molecule, it gains one electron and it forms as a sodium. Pure sodium metal is deposited at where? Cathode electrode, and chlorine, which donates 2 electron and liberate chlorine gas in anode. At exactly cathode, reduction is happened. At anode, oxidation is happened. We already know. Next mode of the flux. What is flux? In some cases, certain metals are not in their oxide form, thus called as a flux. Without oxide forms, metals is there na, they are called flux. Not in their oxide, as it's called flux. Flux combined with other impurities form a slag. With it is mixed with another impurity, then it forms slag. In flux, we have two types: acidic flux, basic flux. These are the example. The method of extraction of metals depends on their temperature. No, sir, it completely depending upon their reactivity series. It completely depends upon their reactivity series. Come on, let's solve here one question. Flux combined with other impurities results in the formation of what? Slaga, ganguina, smelter. This one. Yes, sir, slag. Quiz time. First question, the acidic flux is nothing but metal flux. Answer is SiO2. Acidic, non-metals. Okay, done. Yes, done. Next mode of the session 4. Session 4 is nothing but extraction of moderately reactive metals and less reactive metals. Very important. Students, now we can take we can take one 5 minutes break. Tea break now. 5 minutes tea break. I am back in 5 minutes. Yes, everybody. Come on, let's discuss moderate reactive metals. It's nothing but how many metals are there in this series, students? How many metals are present here? Totally, yes, sir. Magnesium is there. No. Magnesium is highly reactive metals, right? Zinc, iron, and lead. These three are moderately reactive metals. Come on, let's discuss this. We already discussed that one. Yes, moderately reactive metals generally occur in nature. Students, these moderately reactive metals are there now. These metals are occurred in three forms. One is oxide forms, one is sulfide form, one carbonate form. We already know whenever the metals occur in oxide form, what happens simply by using reducing agent, we can easily remove this oxygen. We easily remove this oxygen and we can easily obtain metal. Metal oxide is there, MO is there. We remove this oxygen by using reducing agent. What is reducing agents? What are reducing agents? What are? Who that one? Who that people? Yarido reducing agent? What are reducing agent? Very simple. They undergo oxidation and helps to other compounds. To reduce. Right, my dear students? Helps to other compounds to reduce. Very simple. Right, my dear students, it's correct. For example, hematite ore is there, zinc blend. Hematite is ore of an iron. It is an ore of an iron. Zinc blend is a ore of zinc, and calamine is a ore of zinc. It is in the form of zinc carbonate. It is in the form of zinc sulfide. Very simple. First, we need to convert this sulfide ore and carbonate ores to oxide form, and after, by using reducing agent, we can easily extract a metal. Very simple process. The conversion of carbonate ore or sulfide ores to oxide ore is called roasting. What is roasting, my dear students? Very important question. Roasting, it is a process in which sulfide ores are converted into oxide ores by heating strongly in the presence of excess amount of air. In the presence of excess amount of air, we convert this entire sulfide ores to oxide ore. This method is called roasting. Okay, my dear students, I hope it's clear. Then after this, for example, here zinc ore, we know, right? Zinc sulfide is heated strongly in the presence of excess amount of oxygen. Then we obtain zinc oxide. Is nothing but oxide ore of an zinc, and after, sulfur dioxide is releases. Okay, my dear students. Then calcination. What is the difference between roasting and calcination? Is very simple. Student, the conversion of carbonate ores into oxide ores is called calcination. But in this process, what happened? In this process, we use limited amount of air. Yes, sir. Here also we heat the compound in the presence of oxygen, but in this case we use only limited amount. What we use? Only limited amount of air. Okay, my dear students, I hope it's clear. For example, zinc calamine, zinc carbonate is heated in the presence of limited amount of oxygen. Then what happens? Zinc oxide and CO2 gas is releases. Okay. Then after that, by using reducing agent. Which reducing agent? We have many reducing agents: carbon, aluminium, sodium, calcium. Sodium, calcium is nothing but it acts as a double displacement reaction or displacement displacement. By using this as a reducing agent, for example, if you use carbon as reducing agent, what it form? Carbon monoxide. Carbon monoxide gas is releases. Okay. But here we have few metals. Few moderately reactive metals. Example is manganese and chromium. These are highly affinity, or it react with carbon to form compounds. What happened? Manganese carbonate or chromium carbonate, chromium oxide is forming. That's why what happened? Instead of carbon, we use aluminium as the reducing agent. The reduction of metals oxide using aluminium, it is called as aluminothermy process. What we call this process as aluminothermy or thermite process. It is highly reactive. Okay, highly reactive, not highly reactive. It is highly exothermic. What is the exothermic reaction, or what is exothermic reaction? Very simple. If in the reaction the heat is releases, not heat is absorbed. Heat is releases. This type of reactions are called exothermic reaction. Right, my dear students? This type of reactions are called as exothermic reaction. Here what happened? From this highly exothermic reaction, metals are obtained in form of molten form. Molten form it's obtained in the form of molten. Next, what is the question here? Thermite process is an example, is an dash process, is an exothermic process. Right, sir? Yes, sir. Let's solve here. One question is there. What is the question? Reduction of metals using coke is called what we call this as calcination or smelting, crushing, roasting. The reduction of metals using coke, it is called smelting. Okay. Now move on to the next learning outcome. Extraction of least reactive metals. Now highly reactive metals done, moderately reactive metals done. Then move on to the least reactive. Highly reactive and moderately reactive done. Then least reactive metals is nothing but copper and sometimes silver obtained as the silver sulfide form, Ag2S form. Otherwise it is also obtained in element form only. Gold and other metals are obtained in elemental form. Students, these are the example. These are example of least reactive metal ores. Cuproid ore correspond to copper metal and sulfide ore is nothing but copper glands correspond to copper metal. Cinnabar is correspond to mercury. Very simple, students. Here what happened? Same thing. These least reactive metals obtained in two forms, oxide ore forms and their sulfide forms. What we do, if it's in oxide ores, then we eat only. If we eating alone or if we eat that ore, then we obtain free metal. In this case, what happened? First we need to convert sulfide ore to oxide ore by using which method? Calcination or roasting. By using roasting process, we convert sulfide ore to oxide ore. Then after that, eating alone we get free metal. For example, mercury oxide. Simply do that. Roasting of HGS, we do that. Copper oxide, here one simple twist is there. What is the twist? Simply we heat with other copper sulfide molecule, then we obtain copper and sulfur dioxide gases releases. This is about least reactive metals. And also gold, silver, these are low in the reactivity series or extracted in the process of amalgamation. Amalgamation is nothing but is the process of extracting metals from their ores by adding of small quantity of mercury. Here what we do, we add some small quantity of mercury, then in water outlet, water inlet is there. This is a schematic representation of extraction process, amalgamation process. Very simple. Then here one question is there. What the question? Sodium is less reactive metal. True or false? Let us know. Let us know in chat section, everybody. Let me know in chat section. Anything else, students? Any doubt is there now? Any doubts? Let us know, everybody. If you have any doubt, let us know. What is the answer for this question? Let us know, students. Any doubt, my dear students? As it is false. The answer is it's false. This is a highly reactive. For this question, which metal is added to metals like gold, silver, etc. for their extraction in the amalgamation process? What is the answer? Copper, iron, mercury, aluminum. Let us know the answer. What is the answer? The answer is amalgamation is nothing but mercury. Now it's an quiz time, my dear students. Which of the following is an ore of mercury? Which one? Hematite. Yes, HGS. No, cinnabar. Hematite is an ore of iron. Cuprite, copper. It is also copper glass. Right, my dear students. Next question. Least reactive metals occur in the form of the slag, gangue particle, carbonate, sulfide. The answer is sulfide forms. Next, move on to the next learning outcome. Refining of metals. We already know whenever we buy a fruit or anything, the elders advising you to wash the fruit. Same, we need to do some impure metals. It consists with impure metal. We need to extract that. In the refining metal, what happened? The process of removing impurity from the metal to obtain pure metal is known as metal refining. It is called metal refining. In this method, what happened? The most used method, which method we use? Electrolytic refining. Here, this is a schematic representing what happened here. An electrolyte tank containing acidified CuSO4 solution. Acidified CuSO4. Here, one twist is there. Here, we use anode as a impure copper, pure copper as a cathode. Pure copper, impure copper. Okay, what happened? After the passing electricity, CuSO4, copper, Cu2 plus molecule, what happened? It moved towards and cathode side because it's a negative side, right? It's positive, this one. In cathode what happened? It gains 2 electrons. It's nothing but it undergo reduction in cathode electrode, and pure cathode or pure copper metal is what happened? Pure copper metal or deposit at cathode electrode. Similarly, anode electrode, the size of anode electrode, it decreases. Then here some impurities are obtained. These are called anode mud. Impure metal. At cathode this thing is happen, anode this thing is happen. Very simple. Thickness of cathode is decreases. Anode is decreases, cathode is increases. Okay, my dear students, anode mud. This is called anode mud. Here, what is the question? During electrolytic refining of copper, thickness of anode decreases or increases. So let us know, students. Let us know the answer. Let us know the answer, my dear students. Let us know the answer. Everybody, let us know. Let us know in chat section. The answer is very simple. The answer is it is decreases, right? Now let's solve the question here. Impurities collected below the anode is called anode sludge, anode slag, anode mud, anode gag. You guys have 30 seconds time to solve this. I already explained that concept. What happened? Whenever the electricity is passed, the pure metals are deposited cathode, and the size of anode is decreases. Something is collected at bottom of the anode electrode. What is this called? What is this bottom? What is this molecule, or what is this called? What is we call that as an? Let me know in chat section. Let me know. Students, let me know, everybody. The answer is anode melt. Now move on to the corrosion and its prevention topic, students. What is corrosion? What happened in corrosion? Something is happened, right? In corrosion method, what happened? Very simple, students. Corrosion is nothing but the substance are attacked by surroundings such as moisture, air, acids, air, etc. This is called corrosion. We already know. Sometimes Ag is reacted with H2S, right? Black coating of Ag2S is forming hydrogen gases releases. We already know this case, and this case also we know. Copper oxide, copper, basic copper of carbonate is forming. Well, how to prevent this one? By using some expert. Let's understand the corrosion of aluminium. Aluminium is more reactive than iron. Thus, aluminium comes in contact with moist air in atmosphere where aluminium oxide is formed and get deposited in the form of thin layer over it. Okay, thin layer bandu serkodutte, it form like this. Okay, aluminium. Now move on to the prevention of corrosion. What is the prevention of corrosion? How we prevent this corrosion? It is really important. Why? Because why? We have so much. First one is by using painting. The thin layer or the layer of paint prevents the surface. This is a temporary method, student. After paint gone, what happened? We need to repaint that one. Very simple. Second one, applying oil or grease. We need to apply some grease or oil. We can easily prevent that one. And third one, by painting, oiling, preventing short period of time. Let's discuss for longer period. By using galvanization process, depositing a thin layer of zinc. What happened whenever you deposit a thin layer? First, zinc is corroded and zinc is react with oxygen. Then zinc oxide form. Above the zinc line, another line zinc oxide is there. That's why iron is not corroding. Next, inner chrome plating. The Tiffin box is there now. This is an example, depositing a thin layer of tin or chromium on the iron articles. We can do that. Iron. Now come on, let's discuss one here. Let's solve question. Which gas is responsible for corrosion? Carbon dioxide, nitrogen, sulfur dioxide, oxygen? Let us know. Let us know in chat section, everybody. Let us know the answer. Let us know, my dear students. Please let me know. Let me know in chat section, everybody. Let me know. What is the exact answer? The exact answer is oxygen. Right, my dear students? The answer is oxygen. Yes. Now come on. Now it's a quiz time. Aluminium reacts with oxygen to create a layer of over itself is Al2O3, aluminium oxide. Okay. Formula of rust is Fe2O3. Right, this is a formula. Next, move on to the another important topic. Last topic of today's class. Alloys and question for practice questions and some NEET JEE questions. Okay, alloys is nothing but it is a mixture of two or more. It's a mixture of two or more of metals. It is a homogeneous mixture, student. It is not a heterogeneous. Homogeneous mixture of two or more metals or non-metals. For example, two or more metals. Alloy is brass. Here we mix copper and zinc metal. Okay, a metal and non-metal steel. Iron with carbon. Steel metal. Okay. Here, how to prepare alloy? Very simple, students. Here we need to melt primary metal. First, we heat the primary metal and it's converted into their molten state. After that, dissolving other metal in this metals or non-metals. Another metal is there now. Second metal. By using this alloy or by using this molten state, we dissolve that one and cooling. We cool that, then we obtain the alloy mixture. We obtain that one. Here we have few common examples of alloys. The brass is nothing but it is a which element is present here, which constituent element is present here. Here copper and zinc is present. It is application is cooking utensils and other things we use. Bronze, it is copper and tin alloy. Solder is nothing but lead and tin alloy, use it for welding process. Okay, amalgam is nothing but mercury with any other one. Dental filling, beryllium is nothing but aluminium, copper, magnesium, manganese. Four metals. It is used in aircraft bodies, to prepare aircraft bodies and parts, space satellites, pressure cooker and other things. Okay, my dear students. Next, alloying is done. Copper is a good conductor. What is the use? It increase their property. What happens? Some metals are very good conductor. But by using alloying, we can easily down their conductivity, down their boiling point, or we increase their property. Something is happened. For example, here look here, pure iron. We have two alloys of pure iron, steel and stainless steel. What is the use of this? Both are strong only, but sometimes steel get rusted. After long time, maybe steel get rusted. It's never don't rust. Does not rust. Any time it's not never rust. Here iron and carbon is there in stainless steel. Iron, chromium, nickel is there. Iron, chromium, nickel. Here we have two important knowledge is there. Do you know pure gold? Pure gold is nothing but 24 karat. It is very soft, and that's why we use gold. We alloy gold with copper or Ag. 22 karat. 22 karat is nothing but 22 gram or 22 parts of gold plus 2 parts of copper or Ag. Very simple. Okay. I hope it's clear. This one iron pillar near Qutub Minar in Delhi was built more than 1600 years ago. It contains high content of phosphorus, which prevents in form getting rusted. It is also alloy. In before 1600 years, they have idea about alloy, students. Just imagine about our ancient people. Okay, here question. What is the question? Alloys are heterogeneous mixture? No sir, it is homogeneous mixture. Yes students, come on, let's solve here. We have few questions here. Pure gold is alloy to make dash fit for jewelry, either copper or Ag, right? Either copper or Ag. Either copper or Ag is an answer. Then quiz time. First question. Alloys containing one of the component as mercury is known as. Let me know the answer, students. My dear students, let me know the answer. 1 second. Here's some technical glitch is there. 1 second. Has students, come, let's discuss further questions here. What alloy is done. Yes, next move on to the question for practice. First question. You are provided with 3 metals, sodium, magnesium. We confirm by using water. This metal, sodium, is react violently. The metal which evolves hydrogen gas heating up with one magnesium. These are the 3 marks question. This is the answer. If you want, I post this PPT in Telegram channel. Please join it. Now come on, let's discuss few questions related to JEE and NEET questions. The sulfide ores are converted into oxide by heating strongly in the presence of excess ore. This process is known as, what we call this process? This process it is called as roasting or calcination. Refining, smelting, both are wrong answer. The answer is roasting. Sulfide ore to carbonate. Here in electrolytic refining, the cathode is made up of pure metal. Next, in the mixture, what happened next? It is NaAlO2. It is a formula. Aluminium oxide, it acts as a both, it shows both basic nature and acidic nature. We are already familiar with one. Which one is malachite? This one, option A is correct answer. Identify the incorrect statement. Here, what is the, it is an audition need question. The scientific and technologies process used for isolation of the metal from its known as metallurgy. Yes, it's correct. Here we need to identify incorrect. Minerals or natural. Yes, it is also correct. Ores or minerals that may contain a metal. Gangue is the contaminated. The answer is option D. Gangue is ore contaminated, not. It is a impurities. We remove that. Okay, next question. Metals are usually found as nitrates on their out of their following reasons. Which are true of the above observation? Metal nitrates are highly unstable. The answer is option 1 is false, but second is true. Okay, students, this is about today's class. Come on, let's quickly summarize the. We discussed entire metals and non-metals topic and everything we discussed. If you have any doubt, then let us know in chat section and please give valuable feedback, my dear students. Okay, anything else? If you have any doubts, now let us discuss. Let's discuss in next class. Okay, students.